Hello, everyone. Thank you for joining in. We're going to wait 5 minutes for more people to join, and we can start the webinar right now. Thank you. Hello and welcome, everyone. I'm Mana from Ostorlab, and in this webinar, we'll debunk topics such as vulnerability exploitation, ticket aggregation, and attack surface discovery. And last but not least, security copilot. So in this webinar, it will be led by our panel of experts, and they'll each share their insights on these topics. So the session will be 60 minutes long, and we'll have a Q&A at the end of each session. So feel free to drop your questions in the chat. So let's start now with our first expert.
Okay, well, thanks, Manal, for the introduction. I am going to start by sharing first my screen, quickly introduce myself, and then hopefully kick it off. Okay, so first of all, thanks everybody for attending this webinar. My name is Alaeddine. I'm the co-founder of and CEO of Ostorlab, and we thank you for joining and attending this event. The session I'll be doing today will be focusing on demoing a lot of use cases that we've been experimenting with, and we've had a lot of success, which is leveraging all these advances that we are seeing in generative AI and agentic AI to solve a lot of hard problems that have been battling and challenging for many years. And the goal is really to showcase a lot of those capabilities. What we'll be presenting here today, we will open source some of it. We will also publish a lot of articles and publications on it. But before that, quickly introduce myself. So I come from a technical background. I've been doing penetration testing for many years and moved to product security. I was a member of the trust office at Cisco, then was part of the security automation team at Google. And so security automation is a very close and a topic that I'm deeply passionate about. Okay, so the first, so I'll be presenting 3 cases, which actually showcases the application of generative AI and agentic AI for cybersecurity. And the first use case that I'll be talking about is something which is extremely common in any security tool, in the largest majority of security tool. So so all of them. So if I take as an example, let me here take as an example a tool called Nuclei. Most tools will use some sort of rules which will be written by hand, and these tools would require some sort of analysis and research so that we can bake in all the logic to detect. And if I search for YAML files in the case of a Nuclei template, we will find numerous files which will tell how each vulnerability needs to be detected, and it will have logic that has been researched either based on papers, on blog posts, or on on POCs that are available on the internet. This work of researching a vulnerability, finding the proof of concept, or understanding the paper, building a POC for it that will be used, it will usually take days, and sometimes will take even weeks before we start having something working. So this is an extremely time-consuming effort, and it requires a level of expertise to understand what is, for instance, a command injection, what is a serialization bug, how can I actually understand and leverage that particular vulnerability to both detect it and then go ahead and exploit it. So the question that comes to mind is, can we leverage any of these new capabilities to address that? So what I'm going to be showcasing here is a tool called the generative POC. So let me quickly just increase the font of my screen so that hopefully you could see it. So we have a tool here called Generate POC that we will actually be open sourcing, which given a CVE, it will go ahead and will research that vulnerability. So in this case, it's using GitHub. It will go and then it will search for that particular CVE, any mentions of an exploit, any mention of a proof of concept, any mention of a vulnerability details, and it will leverage that to first understand the vulnerability and then try to build an exploit and a POC for it. So the first thing that actually happens is that when it's doing the research, it will return multiple results. And the first step that will come is, can we leverage actually the AI to find relevant results that can be used? I'm using an example that actually we've already open sourced the detection. So this is why I'm using this as an example. But what it did here is that it found actually a Nuclei template, and it found it to be relevant across 45 results. It found actually the original POC, which was apparently published by Adisec, and then it will reuse all of this information to go ahead and then build a proof of concept based on that. I did already run this. It will actually, while this is running, let me quickly show what it will do. So I did run this just a couple seconds before, and what it did is it actually did the analysis, and then it generated an explanation of the issue. So you could see here, it did understand this is a vulnerability which is affecting this particular endpoint, which is the get hash for wildcard. It found exactly what are the mechanisms to exploit it. It found what is the detection. So this is actually a pingback. It's using Interact SH, which is another open source pingback server, which is similar to actually maintained by the same team as Nuclei, and it generated a proof of concept from the available POCs. This is written in Python, and I have here a very nice explanation of the issue, how exactly I should be able to use it. This is the target I'm given, and then I have the source code which is available and all the resources of that particular finding. So this is something that will give us instead of having to research vulnerabilities, understand how it works, and then build the detection for that particular issue, which can take hours and sometimes days, all I had to do just specify the CVE, and it's able to do the research, understand the vulnerability, build valid POCs, and we could actually push this much farther. We could let it actually go to platforms like Shodan or FUF, and then it will try to find vulnerable assets, test the POC on them, see if this is actually working or not, rewrite this into our framework or technology that we are using, and ship a very useful description. So we can really push this and use a lot of the glue that was hard and to automate, to leverage in this AI to be able to solve that problem. Okay, so behind the scenes, what this is using, so that I can explain some of the concepts. This is, here it is. So this is using, I just borrowed this graph from this very nice gentleman called Eduardo Ordax, which explains multiple patterns when we talk about agentic AIs. So agentic AI is leveraging LLMs in a powerful way. They usually will prompt it with asking it what tools it should be using and also what output format it should be generating. And in this case, we have a simple case here, which is just for the CVE, which is will research that CVE. It will use tools like a GitHub to search the information. It will use it actually to generate source code, which is valid, and then it will print it. So this is a simple use case of a very of leveraging available public information, putting that together, and then we have something that we can use in our automation. Okay. So the second example that I am going to showcase is a little bit more advanced. So let me again share, go back to this and make this bigger. Okay. So what I have here is an automated pen test tool that will perform a very advanced analysis of any particular vulnerability that I need to target. Here I'm asking it to target x.com, just as an example. But what I'm asking it is to analyze the website for authentication vulnerabilities related to its OAuth implementation. So I'm very special. I'm asking something very unique on how I should be able to detect that vulnerability and how I should leverage. If I was actually to do this with a simple any LLM I will ask it, I will typically, it's not going to be able to achieve much. What we are doing here is that we are building an advanced architecture which will leverage multiple agents, which will leverage interaction with these agents to solve the problem. So what will happen here is that the first action that is done by the tool is to understand the context of whom am I analyzing. So it will collect business information about the target. And this actually takes longer. So I did run this before. And let me show you exactly what this actually does to explain actually the logic. Let me go a little bit up and showcase. So here it's actually collecting information about the target. It's researching based on just the website. It's gonna say, what do I need to collect as information? It will scrap multiple resources, and then it will create a let me actually make this bigger. It will create a business context about the target. So it found this is x.com. It is formerly Twitter. It's a social media. It found that it is being used by, it has, multiple APIs like PowerTrack and Deka House. It monetizes through advertising. The platform faces competition from other social media. So it gives me very useful business context about the target. What it does then is that it will collect technical context about the application. And here it found that this is using React, it's using Ruby on Rails, which apparently originally, so it's actually phasing out from it. It's using multiple databases that I'm seeing here. It's using Fingal, which is an RPC system. So there is a lot of very useful information about the system and how it's working behind the scenes. And this is information I got from just running the very generic architecture, not specialized in that particular vulnerability. Once it does that, it identifies what threats do I need to target. So what I was going for is OAuth account takeover, OAuth issues. So it found that among the threat is account takeover, and it listed many of them. And these are then used to come up with a plan. And the plan is specialized for exactly what I asked it for it. So the plan says here that initially it will do reconnaissance. It will identify all the OAuth authentication entry points. It will enumerate the OAuth providers. It will document how the flow is working. It will analyze. So from something which is very specialized, it came up with an action plan, which was not something that it had. And this plan will then be used to be executed by other agents. What happens, however, is that some of these actions, we don't have them in the LLM context. It needs to learn, how do I do certain action? So what happens is that here we have other agents that will research how that task needs to be done, and it will collect information from it, and then it will create a guide that can be used by other agents to leverage this for advanced detection. So we have here the research that has been completed, and we have a very detailed, like this is a very detailed guide on what I need to do to perform OAuth analysis on an application. And it's telling me exactly how to do it, how to analyze the permission, example of OAuth phishing. Like this is a very detailed analysis that was based on something that may not necessarily be within the LLM when it was trained, but it was able to compute that by collecting, by using other tools like research and other public blog post to construct this. And once it used this, then comes the real testing. So it leverages this to come up with what do I need to do. So here it understood I need to go to the well-known OpenID configuration. And then from here, I need to go to the login page. I go to the iFlow login. So it understood these things and it starts to run them, execute them, analyze the results, and then decide what needs to be done. So it will actually iterate over these actions and then decide, did the action fail? Did the action pass? Regenerate documentation for the next action, learn from it, generate more actions. You could see here it now starting to grab for providers to see if there are any authentication. And this was not instructed. It learned this on its own. And it will say at the end, is this action passing? Why is it passing or not? And then say, okay, this task is done, this task is failed. It will continue, keep all the context within a vector database, and it will iterate, loop over, and improve until it's able either to find issues and or stop, because we have a number of limited iterations. So we have here a more advanced example. Let me show of how that looks like, which is leveraging actually multiple examples of AI agent architecture. So it's using planning, where it's going to generate a number of tasks. It will execute those tasks. It will evaluate its progress. And then it's going to also use multiple agents working together, sharing instructions, sharing information, so that they can actually have a way more powerful execution compared to what they just get from the LLM. Okay. So this is a second example. The third one that I'm going to be showcasing is something related to reverse engineering. So what I have here is a mobile application with source code obfuscated. Let me again increase this. And so imagine you are doing an assessment, you're evaluating an app or evaluating even a malware, and what you are looking is code which is completely obfuscated. You have obfuscated variable names, obfuscated class names, and you don't really understand what is this code actually doing. What is it? What kind of action is it supposed to do? How can I actually analyze this to understand its intent and understand what kind of impact does it have, be it malicious, be it security, be it any, even understanding the behavior from it. So in this case, so the architecture of something that would be able to solve something like this. So I have here just a web app which actually shows me the architecture of the application. So any function that we are looking at will typically call multiple other functions. And we can see here that some of this code is obfuscated, but then at the bottom, let me close this, at the bottom, it's gonna call some of the native SDKs, which are actually not, it's going to not be included actually in the mobile application. And we would understand from those, what is the application, but just looking at that function, what is it doing? So if I increase actually the depth and I look maybe at a function that doesn't call any other, so I have one here. So I have one here, which is only calling native SDKs. And this particular function, using the functions it is calling, using the strings and the constants, I can actually understand what it is doing and then use that information to rename it into useful name and variable names, and then pass up the flow until I am able to reconstruct the whole source code of the application. And if I try to run this, so I have this tool which actually will use a call graph, which is just the pickle graph of the app, and I'm giving it the application I would like to deobfuscate, to analyze and give me something which is useful. Okay, so this will start analyzing the whole graph, constructing every function, what it is doing, and then generate a source code of it. And again, I did actually run this just before, and I'm going to show you what it is able to do. So This is the original code. You can see it is obfuscated, and this is the rewritten of the code. And it did actually understand this is N38. It's a daytime dialog utilities. This is already something way more helpful. It renamed the function name into show data picker dialog. It entered some of the context, some of the constants, what they mean. So it understood that this is actually a calendar.year, a calendar.month, a calendar.date of month. So it was able to regenerate significantly more useful code with understandable variable names. I can look at any function and I can read exactly what it is doing. And it really saves significant amount of work going over the code, renaming each variable, understanding what it does by just providing it with powerful context, which is, for instance, what is the call, and doing a recursive approach, traversing the call graph. I'm able to automate advanced actions that would have required a lot of human efforts to perform. Okay, so what I showed today is 3 examples. I have the first one, which is related to generation of rules. Just we give the CV and it's able to analyze proof of concepts and be able to give us something which is valuable that would have required significant amount of analysis. I have shown an example where we are pushing the boundaries of what automated tools can do and how we can leverage them for more advanced vulnerability classes, how we can instruct them not to just do an analysis. We can say, please target and OAuth vulnerabilities. Please target IDOR vulnerabilities. Please target, I have this particular API, works in this way. Please target this kind of vulnerabilities in the app. And we can now even leverage it to looking at, be it a malicious code or a normal code that is obfuscated. I can completely beat that, regenerate extremely useful code that I can understand, and I can even pass to other automation in place to detect other classes of vulnerabilities, logical vulnerabilities, or technical vulnerabilities within the application. So I hope you have found this useful. Happy to answer any questions. Otherwise, hope to pass this to our next. So I do have a few questions. Is the photo going to be available? The code. So yes, so we are planning on open sourcing some of these tools. Among them, there is actually the deobfuscation and the POC analysis, and others we will publish in-depth articles. What I've seen here is just demos. It actually requires significantly more efforts to go over how this is working, but it's something we definitely are planning to do. Okay, so I think with that, I'll pass the floor to the next person. Which models are you using for the deobfuscation and reverse engineering? That's actually a very good question. So we have experimented with many models, and many they actually have different levels of quality and cost. In general, low quality models will either miscode or will generate hallucinate. So you need actually very high quality models to be able to generate high quality results. So the model that we've seen actually work are all the modernist models. So you go from DeepSeek Chat, O3 Mini High, 4.0, and upwards up to 3.7 Anthropic. Those are models that perform very well. But of course, what really, really matters is the context. What you provided as context, that's actually key for having high quality results. Have it found any real world bugs? Yes, it did. We have actually multiple vulnerabilities that we report. We are integrating this into our automation. And yes, we are even leveraging it to start identify. It's not something I can share, but yes, it did actually find interesting bugs. Okay, so I think since I'm out of time, Amine, I'm going to leave the floor to you, and good luck. Thank you.
Thanks, Alaeddine, and hello, everyone. And welcome to our webinar on Ostorlab security aggregation feature. So I am Amine, CTO at Ostorlab, and today we'll be exploring one of our important features that addresses the critical pinpoint regarding the vulnerability management. But before we dive into the solution, let's first understand the problem that many security teams face. After every vulnerability scan, organizations they are confronted with a massive volume of findings. While automated scanning tools identify issues, actually the real work begins when trying to make sense of these results. And actually the security teams, they face 3 main challenges. So the first one is the triage burden. Security teams, every time, they often spend hours manually reviewing each vulnerability, try to classify the findings, track the status of each issue and finding, prioritize the issues, and assign ownership. This is a tedious and an endless work. The second issue is the false positives. They remain a persistent challenge in vulnerability management. Why? Because the team first, they need to analyze the context, understand if it's a real or true positive or a false positive. They need to document why they decided to mark it as a false positive. And of course, they need every time to update the system to make sure that next time they will not be processing the same issue and keep the history of what was processed before. And the last challenge is the fix identification gap. And here we are talking about, did we implement the right fix? Is it implemented on all our stacks across the different teams? And how are we going to monitor those fixes during the time and while evolving in different scans? So with those challenges, they can lead to inefficiency and increased risk exposure. And this is why the moment we built Ostorlab, it was not only to automate the security detection, but also to leverage the vulnerability management lifecycle and make sure that the teams have a structured workflow that can help them and assist them during the remediation part. So Ostorlab has an in-house ticketing system, which is tailored to vulnerability management. It helps to automate the triage actions, handle the false positives, and also validate the fixes. How it is done? This is via what we call the vulnerability DNA. So the moment we run a scan, every vulnerability, so if I go to one of our scans here, we open one of the findings, every vulnerability has what we call a unique DNA. That DNA is computed to uniquely identify an issue across the scans. And every time we run a scan, what we'll be comparing that finding with is its own DNA. So if we take an example here we are conducting multiple scans. The first time we run the scan, we will have a new finding, which will be computing its DNA. It is the first time that we are seeing it. So we are going to open a new ticket with the status open. Next time we are going to run a new scan, what will happen is that we already know that DNA, so we will not be opening a new ticket. We will just amend that scan to the existing ticket. This is already very useful. Why? Because the teams, they don't have anymore to compare the scans and to say, this is new, this is a duplicate. The platform will do that automatically for you. This can go even better. The moment we run a new scan and that issue does not exist anymore, so we don't see that DNA in that scan, the platform will automatically mark that ticket as fixed and verified. So even the fixes, we don't have to validate them anymore. The platform can do that for us automatically. Let's say in 2-3 versions later, we run a new scan and that issue reappears. The platform remembers that DNA and we will be reusing the old ticket. So it will be reopened and it will have the status reopened. So if we had comments on that ticket, if we had code exchange, if we already assigned an owner, we don't lose that context anymore. The platform will help to have an efficient remediation flow. It goes also to false positives. If I mark a ticket as a false positive, it has the same DNA. If that issue pop up later, we remember or we know that it was marked before as a false positive. So we will not bother the development and the security teams with that issue. It will be automatically marked as a false positive. So this is already good, and it is helping a lot the security and development team to reduce the manual work to do it. But how can we make it even better? One of the challenges that we saw with our customers is that the way they would like to manage the ticket can vary from one organization to another. For example, if we have one application on a dev version and the prod version, do we want to have them in the same ticket, or do we would like to separate them in different tickets depending on who is managing what? If we have a white label application, do we need to have one application, one ticket for all the applications, or we separate them based on the number of applications we white label? So those are the scenarios or the cases that we saw from our customers. And the solution to this was the ticket aggregation version 2. This version, the main release or the main feature in it is giving flexibility to our users, how they can customize and how they can play with the aggregation feature. So how does it work? Let's go with the real use cases. Let's say you are developing a mobile application on both Android and iOS, and your development team, they will be uploading the EPK and the IPA file to scan against the dev version. But the security team, they scan from the Play Store and the App Store, and they would like to monitor the tickets for the production version. So the requirement is to have separate tickets for each environment, the dev and the production. How does it reflect? We would like to have for the Android APK, if we find an SQL injection, to create a first ticket. However, if we scan it from the store, it should have a separated ticket, and the life cycle of fixing it on the dev will be different on the store. This applies also to the iOS version. So how does that work on the platform? If I go to the ticketing system, and then we have what we call the ticket aggregation configuration. So here we have two modes, the platform and the application groups. Since we are talking about the same application, we'll be working only on the platform groups. With this configuration, what do we say? Every source of the scan will have its own ticket. For example, if I scan the application from the Android, it is a separated group. If I scan it from the store, it is a separated one. With this configuration, if we go to the remediation, we can already see that I have two scans for the same application. They have exactly the same issue, which is an OpenSSL outdated dependency, but they have two different tickets. So we are already answering this request to separate them. But let's say we have another organization. They are managing both the dev version and the production. So what they would like to have is one ticket, which is aggregating both the dev and the application from the store. So if I scan the application from the APK or I scan it from the store, they should be tracked on the same ticket, and the same goes to the iOS version. How can we do that in the platform? So if I go back to the settings, and this time, instead of having two separated groups, I will group them only in one, okay? And then we'll do the same thing for the iOS version. So I will group the iOS either from the store, from test flight, or by uploading the IPA file in one group. And now, if I hit update, what I expect to see is that all the tickets, so the one that we saw before for the Android and iOS, now they are within the same ticket. And if I go here and I click on scans, I can see that we are tracking now both Android from the Play Store and from the APK in one ticket. This is very important. Why? Because if we would like to fix this ticket, if I scan the application on a higher version, then both the Android APK and the Play Store should be fixed, so the ticket can be marked as fixed and verified. So the team, they don't have to manually track those. The platform will automatically follow up on that. Even to make the life easier, if I scan the application from the Play Store on a higher version, so let's say 1010, the platform will understand that you already went through the full process and you did fix it on the dev and scan it from the store, so the ticket will be automatically marked as fixed and verified. So many of the manual work to manage this case is automatically handled by the platform. Let's see now another use case, which is we have different dev environments. So we are having the dev, the QA, and production. And in this case, the application ID is different. So we are not scanning anymore when we analyze the application, the same app, because we have different applications ID. The normal use case is that if I scan the dev and I have a ticket, I have an issue, it will have one ticket. If I scan the QA, since it's a different application, it will have its own ticket, and the same goes to the product. But one request we can have is that, no, we would like all those application IDs to go through the same ticket, and we need just to manage one ticket for the full life cycle of the application. So it means that whether I scan the APK from the dev, from the QA and prod, they should all have the same ticket, and inside they can follow that. So if we go back to the platform and I go to settings, now we are not anymore talking about a single application. We are talking about multiple applications. So in that case, we need to switch to the application groups. What the application groups allows us, in addition to defining the platform, I can say, sorry, Android file, I can say I would like to have any app which is com.myapp.dev or Android file.com.myapp.qa and Android file myapp.prod. I would like this combination to get aggregated within the same ticket. So with this combination, now we can have one ticket, no matter if it's the dev, the QA, and production version. And if the issue is fixed on one but not on the others, ticket will remain open. The ticket will be marked as fixed and verified only if all the platforms has that flow fixed in them. So this is giving a huge visibility to the team to understand where we stand, what are the fixes that were applied, and what is missing. Okay. Another use case similar to this one, but it has a specific particularity. So this is the white label mobile applications. Let's say we are using our core application, but we are sharing it with all our customers in the way that they have com.android.myapp customer. So in this case, you will have customer 1, customer 2, customer 3. So how can we aggregate all those tickets? So instead of have 10, 20 tickets for each customer, we would like to have only one ticket that we can follow and understand the behavior. This use case is a bit similar to this one. The only difference with the one before is that here we know exactly the number of environments we have. So we were able to set exactly the identifiers, while in this one, we don't want every time we add a new customer to put the rule and to update it. So how can we do that in the platform? Simply by supporting regular expressions. We already saw here that we have two scans, com DeepSeek and the Android and Secure Bank. What I will be doing is aggregating all the tickets based on the common point, which is com.something. So if I go back to settings, and I say I would like to aggregate based on the application ID, and this time I would like to have everything which is com.something to be aggregated in one group. And I will do the same thing to the Android store. So by doing this and updating my rule, now if we check back our remediation, if I look for example, the has fragile user data, I know that this issue is common between Unsecure Bank and the DeepSeek application. And as you can see now, we have one ticket which is aggregating all the issues for both versions. So with this feature, we can now easily track one ticket, one vulnerability across either the same application on different platforms or within multiple applications based on the organization need and based on how the internal processes are working. This can help the organizations to one, ease the tracking of all the vulnerabilities, but at the same time, give more visibility about what is fixed and what they need to address. That was for the ticket aggregation feature. Happy to answer any questions, and do not hesitate to give me your comments if you have any. So I have here one question. How is AI integrated in the ticket aggregation? Actually, no. So in this part, the AI is not part of the ticket aggregation because why we base on the DNA computation. So those are specific characteristics that we get from the application. And for the aggregation field, this is a set of attributes that you set. It gives more visibility to the user, but we don't require AI on this part because the data we already computed from the tickets and the vulnerabilities themselves. Okay, so if we don't have any other questions, I will pass it to our next speaker. Okay, we have one question. Is ticket aggregation just for mobile apps? No, actually the ticket aggregation is for all the assets that we support. So the moment you run a scan, either on a mobile application, the web, and the network, the DNA will be computed based on a set of characteristics of the vulnerability itself, including, of course, where that vulnerability was found. And for the aggregation, it is set based on the application. For example, here, for a mobile application, it's the application ID. And of course, for the web, it's going to be the URL, the subdomains, and for the network, it's the IP range. So depending on which asset you would like to aggregate, you will have the set of information you define. Thank you very much, and it is your Rabson.
Okay, so hello everyone. Thanks a lot for joining our webinar today. My name is Rabson, and I'm a software engineer here at Ostorlab. And I'm also one of the people that worked on the AI automated attack surface, which is what I'll be talking about today. Okay, so if you can see on my screen here, this is the attack surface. It's a feature that we have on our platform. And on my left, these are the assets that belong to my organization. And these assets can be mobile applications, subdomains, domains, IPs, or even autonomous system numbers. And on my right, I have a graph which shows me how all these assets are connected to each other. And this gives me an overview of my attack surface. So the attack surface, simply put, we can describe it as all the different entry points or potential weaknesses that attackers can use to find vulnerabilities in my system and potentially exploit those vulnerabilities. And so it is very important for us to know our attack surface, because if we have assets that we are not aware of, it is very easy for those attackers to then exploit any vulnerabilities that exist in those assets without our knowledge. Okay, and so if I can zoom in here just to show you the assets that we have here, we have different assets. We have IPs, we have subdomains, we also have coordinates and certificates. So this indeed gives us a general overview of our attack surface, which are the assets that we own and potentially own. And so I'm going to switch to an empty organization to show you just how we were able to arrive to this attack surface. So I'll switch to an empty organization and I'll go to the attack surface. Okay, so let's assume my organization is Tesla, okay, and I want to view my attack surface. What I'm going to do is I can come here to add the new asset. I'm going to select an owner who will be assigned that asset. And then I'm going to say I want to add tesla.com because I own it and it's part of my organization. I click confirm, and there it has been added to my organization. And here I have a graph which shows the discovered assets that potentially belong to Tesla, which is my organization. And I can see here in the table of discovered assets, all the assets that potentially belong to my organization. So that's the first phase. And now comes the second phase, which is since we have all these discovered assets, we now have to come and then decide whether they actually belong to Tesla, which is again the organization, or not. How do you do that? Let's take this IP for instance. Okay, let's take a random IP and we can copy it. Now we have to look up the who is information to see if it belongs to Tesla or not. So how we can do that? Let's say we can look up the who is information, and if we check, that IP belongs to Microsoft. And it appears here probably because Tesla uses one of their services. And so what we can do is, if I know that it does not belong to my organization, I can exclude it to say this does not belong to me, so remove it from my organization. And if, for example, you had an IP that you know belongs to you, we can quickly confirm it. We add an owner and save it, and then it will be added here to the list of assets that I own. Now, this works. This whole process of getting IPs or subdomains or whatever assets and then verifying their information to see if they belong to my organization, it works. However, it comes with a limitation, which is that it is an extremely manual process and it's very time consuming. I have to go to all of the assets and then check by hand, one by one. Does this belong to my organization? Okay, confirm. It doesn't belong to my organization, then I can exclude the assets. And because it's a very manual process, it's very easy for me to miss some assets that may belong to my organization. And that will not give me an accurate view of my attack surface. And if I don't have knowledge of some of the assets that I own, again, it is very easy for other people with malicious intent to be able to go to those assets, find any vulnerabilities and exploit them and gain access to our systems, which is not good. Another thing is that the attack surface is something that constantly changes because we can add new assets, we can delete old ones, and we can change the configurations in our system. And therefore, I have to come to manually update this attack surface to make sure that it is up to date and we have a correct overview of what we own. So what if we can actually take this a step further, make it better, and optimize it. Well, this is where AI comes in. So what we have here, if I can come here, so imagine just from a simple prompt, something like list all assets belonging to Tesla. With a click of a button, we can have the list of assets that are known to belong to Tesla. And then once we confirm that they belong to our organization, then we start the automation process. So let's see that in action. So I'm going to say list all assets belonging to Tesla. And then I'll say include its acquisitions. Okay, so Tesla's acquisitions. And now I'm going to hit discover. And what the AI agent is going to do is that it's going to see the assets. It's going to give me a list of the assets that are confirmed to belong to Tesla. I can select some of them to say, okay, I only want these ones, that the ones that I know belong to Tesla, or I can select all of them. And the prompt can be refined to get different results based on what we're looking for. So now, once I click confirm, these assets will be added to my organization. And here I have the list of all these assets. So I didn't have to manually add each one of them one by one. I just used a simple prompt. It gave me a list, and with one click of a button, all of them were added. Now, that's the first phase. The second phase is where the magic actually happens. Okay, so remember the process that I was doing of vetting the applications where I had to come. I look at an IP, I copy it, and then I come here and look up the information. The AI is going to automate that entire process. So something that would potentially take days, as you can see, this graph is very huge. So something that would potentially take days doing manually, the AI can do it in just a few hours. So it is going to do the same process, get each asset, look it up, get the information, and based on different verification rules, it's going to decide whether it belongs to my organization or not. And since this process, the automation process, takes a few hours to complete, I did run it in advance so that we can be able to see the results of the automation process. So firstly, if we come to the AI agents page, we can see that I did use the same prompt that I used in the previous organization. And these are the results that we got from that. Okay. So here you can see firstly that we do not have any discovered assets. Why? It's because the AI was able to go through all the discovered assets, and then it was able to vet them. It was able to, for each one of them, it was able to determine, does this belong to Tesla or not? If yes, it confirms it. If not, it rejects it. And so that's something that I was doing by hand, each asset manually. The AI was able to automate that entire process. And we can see that if we come here, this is the list of all the assets that were confirmed. And if we take this asset, for example, and we open it, and we come here to this asset, and this is the good part about the automated attack surface using the AI, because for each asset that it confirms, it gives me a reason as to why that asset was confirmed. So for example, here it tells me this IP was confirmed because it's very likely owned by Tesla based on the WHOIS information that it was able to retrieve. And indeed, we can verify that it belongs to Tesla. We can copy this IP. We can come here and paste it, look up the information, and we see that indeed it does belong to Tesla, as the AI agent was able to reason. Okay, so this saves us a huge amount of time, and it also gives us a good reason as to why it was confirmed. And if I have a colleague, for example, in the same organization, they can come and see, why is this IP here? Oh, they see there's actually a note and the reason why it was confirmed. So let's look at now the rejected assets and see what the AI said about the rejected assets. So we'll take the first one. And again, the AI is telling me here why it did reject this asset, this IP, and it says it's because it resolves to Akamai technologies, as indicated by the WHOIS information that it was able to find. And it tells me what Akamai is. It says it's a CDN and it is not owned by Tesla, and because of that, it does not belong to Tesla. And again, we can double check this just to make sure that it's accurate. We can come here, look up the information, and we see that indeed it does belong to Akamai Technologies. So I'm going to close here. And so we've seen just how AI has enabled us to automate the entire process of verifying these applications in these assets in our attack surface, whether they belong to us or not. It is something that would normally take a lot of time, something that is very error prone, and the AI was able to take that, reduce the amount of time, and remove the burden of having to do it ourselves. So what have we seen from this feature of the AI automated attack surface? From something that would take a lot of manual work and a lot of time, to simply writing a simple prompt in an input with a click of a button, the whole process becomes automated, and the AI is able to tell us why that asset was rejected or why it was confirmed. So this is the AI attack surface that we have on our platform, and you always feel free to be able to go to the platform and play with it, see the different results that it gives you, and see just how much it makes your life easier. So that's it for the presentation. At this point, I'll be happy to take on any questions if there are any. Otherwise, we can move to the next speaker. Okay, I don't think we have any questions. Okay. Okay, so if there's nothing else, then I'll leave the floor for the next speaker.
Okay. Okay, I'm up. Okay. Hello, everyone. Thank you for joining us today. My name is Mouhcine. I was one of the lead engineers behind the Ostorlab security copilot. Today, I'm excited to show you or to introduce you to Ostorlab copilot and how it can make your security operations faster and easier. Ostorlab Security Copilot is an AI-powered assistant that simplifies the way that you interact with Ostorlab platform. It allows users to ask questions, automate tasks, and get real-time support through a conversational interface. It makes complex security tasks that may take you minutes or even hours be done in a way much faster way. So essentially anything you can do from the UI or from the buttons and UI elements, you can do it from or through Copilot. So I'm here on Ostorlab platform, and if you go on the top right, you can see an icon where you can interact with Ostorlab Copilot, and you can ask it questions or give it tasks to do for you. So for the sake of this webinar, let's take Copilot in a real-world scenario where I will handle a specific case or a specific vulnerability. If you see here at the latest threats section, there is a new CVE that is trending right now, and it's apparently impacting one of my assets, and it is related to Apache command. So I'm going to ask Copilot if I have, let's say check my inventory if I have any assets that are related to Apache. So Copilot, what it's supposed to do now is to go to my inventory and search for any assets or IP address or web application that is related to Apache command. If I go here to my inventory, you can see that I have some assets, and one of them is a web application that have a fingerprint of Apache Camel. And Copilot is smart enough to go and to know what to search for and to find that asset. And if you look here, you see that is indeed did find the asset and create and return it. So I did find now the asset. What I need to do is to create a web scan for it, to scan it for that specific vulnerability, or to just a web scan to check it. So what I will do is I will ask Copilot to create a web scan for this asset. And of course, I can go through the UI. I can click new scan. I can go select web application, white domains, check all the configuration here that is available, and create a web scan. But since I do have Copilot, I don't need to do all of this. I can just send it a message or a prompt, and it will create a scan. And if you see here, it did create the scan for me, and it did configure it, and the scan now is scheduled to be run. Another thing I want to do is that I don't want to run just a single scan for this asset. I want, for example, to scan it each week or each 15 day, or let's say each month. So Ostorlab does already have a feature that allows you to do that, which is monitor rules. Monitor rules is a simple configuration that you can do where you say, I want this specific asset, such a web application or mobile application, to be scanned, let's say, each 15 days. Of course, again, I can go here through the UI, check the configuration, learn about all of this, and learn how to do it, or I can go to Copilot and ask it to create a monitoring rule for the asset that we have. Let's say to run a web scan each Sunday at 9 p.m. And Copilot is actually smart enough to go to monitor rules and to understand all the options that are available and to create it for. So let's give it just a second or two to create the monitor rule and check on that. It's taking some time. It says that it's done. Let's verify that. And if I go to scanning, monitoring, you can see that it did create the monitor rule for that target. I asked it to do it, and it was smart enough to know that if I want to scan it each Sunday at 9 p.m., I need to do a cron, and it did to write actually the right syntax for me. Since now I created this monitor rule, I did create my scan for the asset. I wanna understand better what is that CVE I did so before and what are the details. If you are not familiar yet with what is Threat Center is a feature or a section in Ostorlab where we aggregate hundreds of resources across the internet, and we try to detect if there is any new CVE or new vulnerability that is trending or it may impact you. We do create a fingerprint for this, and we notify you if you have any asset that is impacted by that vulnerability. For example, the CVE here, as we saw before, we have one impacted asset, and you can see that the Threat Center is showing us that in here. So I will go to Copilot and ask it to check Threat Center if there is any new issues that are related to Apache Camel, and Copilot is supposed to go search the Threat Center and check for those CVEs and give me more details about it. So let's just give it a second in here, and it will see what will upload. It's taking some time because it needs somehow to know the CVEs, to search for the CVEs on specific databases and give me some details about it. As you can see here, it did indeed give me the description of both CVEs, and also it gave me some recommendation how to fix them, and also a code command that I can execute to verify or to exploit this vulnerability. Now, what I want to do next is that I want to create a ticket with those details, or at least the remediation details, or how I can fix this vulnerability, so I can probably check it later. So what I will do is I will ask it to create tickets and put the recommendation, this recommendation of how to fix it in the description. So I will say put the recommendation in this description here, and it is supposed to go to tickets and create that tickets for me. So I will just give it a second here to run. Okay, as you can see, it told me that it did create the tickets, and if I refresh my page, I can see that I have the ticket that was created, and I have details about it, such as how to mitigate it or how to fix it. Now, one thing, or one last thing I want to mention is that Copilot, when you are interaction with it, is that it is context aware. So it does know where you are on the platform, and does know what you are looking on, and this can understand that. So if I create a new conversation and ask it about this remediation or this ticket, it will understand that I'm talking about this ticket and give me or answer my question about this specific ticket. So one last thing I want to do here is that I want to create something way more complex, which is I want, whenever there is a new ticket that have, let's say, a specific tag, let's say Apache Camel, like a ticket like this one. Let's just fix this. Let's say whenever there is a ticket that have Apache Camel in the tags, I want to add another tag to it, which is called urgent. Ostorlab does, we do already have a feature for that, which is the automation rules, where you can, for example, let's say I want in my inventory, whenever there is an asset that matches Jira, anything, and it's a web application or a domain, I want to add, for example, let's say to this. For example, in my inventory, wherever there is an asset that matches Jira, I want it to add a specific tag to it, or notify a specific user or specific email for this. You have a typo here. Let me just fix it to show you better results. So I want to say, whenever a new asset like this ones is detected, please add a tag to it. And it's supposed to add this stuff. Of course, I can go through the UI again. I can understand all about those options and features and what you can do about them, or I can just go to Copilot and ask it to do that for me. So what I will do is I will ask it to create a new monitoring rule, that selects let's say tickets with tag Apache Camel and add tag urgent to it. So Copilot now is supposed to understand what is required and go and create that rule for me. I don't have to understand what are the options, what I'm supposed to put in here, what I'm supposed to filter with. It will be smart enough to go and understand what's supposed to do and do it for me. So let's just give it a moment to do it and see the results. I think I have some internet issue. Let me refresh my page. I think I have some internet issues. Let me ask it again to do it. Oh, I think I have some checkpoint here. It's supposed to be mentioned. Okay, so let's wait for it. Meanwhile, if you have any questions, it says that it did create it for me. If I refresh my page, yeah, I can see that it did understand what it's supposed to do. It did give it a name. It did filter on the Apache camel tag, and it did an action to add tag urgent. So if I do edit on this, and I see here that it did create the automation rule for me. Okay. So finally, just if you have any questions, please feel free to ask, and feel free to go to Ostorlab, test it yourself, and see what you can do with it. And I think it's I think I have some questions. Can Copilot summarize the findings of a scan? Is sorry, can Copilot summarize the findings of the scan? Yes, it does. It is able to summarize the findings of a scan. You can just either go on the page of the scan and ask it, and it will give you every details that you want about that scan, including vulnerabilities, tickets, the asset, and any information that is available about that scan. I think I have another question. Is it capable of explaining a vulnerability and possibility generation a fix for me? Currently, Copilot does not have the ability to generate a fix for you as it is, but we do have currently a project which is an integration with GitHub that can actually suggest fixes for your vulnerabilities. So Copilot as it is now is not, it does not generate fixes for you, but it is able to explain vulnerabilities for you. Does Copilot require specific training for each organization, or does it work out of the box? Okay, so Copilot doesn't need any training or any configuration or any extra configuration. Anything that you have access to as a user, Copilot does have access to, and it can use it to answer you or to perform tasks for you.
Sorry, Mouhcine, just to add to what you mentioned about the fix
Yes.
generation, we do actually, the platform during a scan, when it actually generates recommendation, there is a mode where it generates fix for you. That's actually already supported. It's not related to Copilot. It's a separate feature which is also using AI capabilities, and it is able to generate exact recommendation fixes. I mean, if you have a sample of the scans, we can show us, but that's something we already support.
Sure.
Sorry, Mouhcine.
Yes, yeah, sure. I don't think I have any examples in here, but yes. Next question: can it help me navigate the platform? I'd like to do something manually. Yes, of course. I think, Ashman, what you are asking for is if you have questions on how to do stuff. I think I suppose this is your question. Like, for example, I can ask it how to create a web scan, and it's supposed to answer me and to guide me to the platform to how to create a web scan. So let me just, for example, ask it how to create a web scan, and it will guide me or give me all the steps that I need to perform that task. Of course, this is about all the features and all the options in Ostorlab, not just a web scan. I have another question: what measures are in place to prevent any general persons from introducing security risks or false positives? So, Zakaria, your question is how do we prevent Copilot from performing unwanted actions or introducing security risks? So basically, the Copilot have only what you as a user can do or can perform, and it doesn't have access to destructive actions. It can just do what you can do as a user. Okay, I think that's all the questions. I will leave the scene to Manal. And again, thank you everyone for attending the webinar.
Hello, everyone. So this wraps up today's session. A big thanks to our experts for sharing their expertise, and thank you all for joining us. So this webinar will be released as a video, so make sure to check it. See you next time.